I would like to describe a field in which little has been done, but in which an enormous amount can be done. This field is not quite the same as the others in that it will tell us little of fundamental physics, but it will tell us much about the strange phenomena that occur just below our perception. In contrast to the natural philosophers of the past, the scientists of this field delve into the recesses of nature and show how she works in her hiding places. Their quest is to understand and create the imperceptible. After all, there is plenty of room at the bottom.
Hello and welcome to the Materialism Podcast, an exploration of the past, present, and future of material science and engineering. My name is Taylor Sparks, and I'm an associate professor of material science and engineering at the University of Utah. And as you know, I'm here in the United Kingdom for a year. I'm on a sabbatical at the University of Liverpool. And again, one of the big things that I was trying to do during the sabbatical is connect with the UK materials research community. And one of the ways I've done that is obviously visiting universities, presenting seminars, but also with this series sponsored by UK Research and Innovation, and more specifically, the Innovate UK and Transforming Foundational Industries Challenge. Now, this is a funding agency in the UK dedicated towards a lot of things, spanning arts and science and medicine, but also materials research. So today, we're going to be continuing the series of episodes that we have on a variety of different topics related to material science and the future technologies of foundational industries, glass, metal, paper, things like that. And in today's episode, I have a bit of an interesting one because we're going to talk about industrial symbiosis as it relates to these foundational materials. And to do so, we're going to be joined by two awesome participants. We've got Anne Velenturf of Leeds University, where she is a senior research fellow with emphasis on circular economy, and also from Chris Holcroft, a principal technologist at Glass Technology Services. Welcome to the show, guys. Could I have you introduce yourselves?
Yep. Good morning. Hi. So I'm Chris Holcroft, Principal Technologist at Glass Technology Services. I've always had a keen interest in nature and the outdoors environment, enjoy outdoor pursuits, and inspired through my parents and primary school teachers, I think, to go into environmental science and the science interest. My earliest memories helping my dad with his university degree experiments, bouncing rubber balls around the kitchen, and followed that up, went into marine biology as a degree. Finished that, somehow ended up working in the food industry, and that's led me into the glass industry. I wanted to get back into...
Hold on. So marine biology to food to glass. Well done. Well done. I'm a fan.
So now I'm living in Sheffield, which is about as far away from the sea as you can get in the United Kingdom. Doing all sorts of... I've developed a passion for glass as a material. It's a fantastic material, doing everything from making bottles and windows through to laser media, bioactive glasses that go in the body to help heal tissue and bone. And we've developed a glass material that's helping to strengthen rocks and stop soil erosion now. Really fantastic material. And I've kind of gone up full circle because now we're trying to work on a glass that helps with environmental remediation and regrowing marine environments. So I'm pulling it back towards the marine biology now.
Fantastic. Welcome to the show, Chris. And you want to introduce yourself?
Thank you, Taylor, for having me here today. I'm really excited to be talking industrial symbiosis and circular economy. It's been a long trajectory to get here, though, because from my background, I'm trained as a zookeeper originally. And from there, I went into nature conservation. And of course, nature conservation, I soon realized that actually nature is perfectly capable of taking care of itself. And it's actually people who need to be managed. So I specialized in participation process management. And that is now what I do in my job. So in my job, I facilitate sustainability transitions for circular economy. I bring people together from industry, from policy, from civic organizations and academia to pilot and to implement circular economy solutions together. Circular economy is all about using less materials. Of course, here I link back to the nature conservation because most of the degradation that we see in our environment is actually caused by the overuse, the overconsumption of resources. So reducing resource use and making better use of materials and components and products is an essential part of conserving our environment. So that is my personal driver for working in this subject area. I did a PhD in industrial symbiosis, and industrial symbiosis is a part of realizing a circular economy to turn waste into input resources for new production processes.
Okay, fantastic. What a diverse couple of people to interview. Interesting backgrounds to end up to where we are today, which is going to make it for a great episode. So thanks for that introduction and for that explanation for our listeners who had never heard of industrial symbiosis before as a term. Can I ask you guys, What is it that generally interests you about this topic? Why are you spending your time on this topic and not many other things that we face as a society?
I think, as Anne says, the nature is perfectly capable of looking after itself. I think the question is how the humans interact with it, and the big question is we've got a limited number of resources in the environment. If we can use those as carefully as possible so we don't deplete them so quickly, give nature and the planet a chance to sustain itself. And this idea of one planet living, it's very logical from my background's in biology, and it's logical. You don't use more resources than you need. And the whole resource efficiency, industrial symbiosis idea feeds into that. If we can make the best use of the resources we have, that gives the best chance for both the environment, the natural environment, and the human population to have a long and sustainable existence together.
I've had a sort of maybe it's an axe to grind on this topic for a while, where people are really interested in green energy. And as long as it's green, what could be bad about it? And if you look at resource utilization and reutilization, actually, we have a long ways to go to improve the current embodiment of green energy, for example. There's a lot of resources that go into those. They're not being recycled very well. We have a lot of work to do. So I'm excited to have this conversation. And how about you? What brings you to this field specifically? Or what interests you in this field?
All right. So I got into this subject following my PhD. So I specialized in participation process management. Participation processes are all about how people are interacting with each other in social networks. And industrial symbiosis is also like that. And that's what I investigate. So I investigated how companies, or rather people in companies, are identifying potential partners for industrial symbiosis, and then how they go on developing that relationship into an actual resource synergy in which a waste is being used as a resource. And quite often what we found is that markets and governance, they also have to evolve with industrial symbiosis. And so I investigated how these networks of industrial symbiosis, how they are co-evolving with changes in markets and policy systems as well.
Okay, I think I kind of, from what you're describing, I have a general feel for what industrial symbiosis is, but I am a very learn through context learner. So can you give me an example of industrial symbiosis that maybe our listeners can connect with?
So I think on its simplest level, it's taking the waste from one section of industry, ideally as it is, and putting it straight into a second industry and using that to replace a traditional raw material. And then on a true sort of, or in the ultimate vision would be for that second industry, if that had a waste, that would either go back to the industry that had supplied its waste to it or onto a third industry. So it's basically starting to see waste or getting rid of this concept of a waste material. It's no longer a waste material, it's a resource. And that can be used. An example from the glass industry is obviously there's traditional glass recycling where glass is finished with by the consumer, that's taken back, goes back into a glass furnace to make new glass bottles, new glass windows. And so that's a well-established model. But taking that a step further, there's a material called Kolobyte, which is essentially blast furnace slag that's taken from the steel industry, processed fairly simply, just cleaned up a little bit, crushed down to a size, and that goes in as a raw material substitute into a glass making process. So you're taking that blast furnace waste from the steel industry, instead of that getting landfilled or going to a low-end use, sort of such as an aggregate fill, that's used as a glass raw material. It improves the melting efficiency of the furnaces, reduces some energy consumption and associated carbon.
So it's not like a major component of the glass, it's an additive just for the processing conditions, or what exactly is it doing?
It replaces a certain amount of those raw materials. In the single figures percent, but it's still a reasonable amount, and that obviously replaces sand that needs to be quarried, limestone that needs to be quarried, and similarly with the recycled glass, as much recycled glass as you can get into a glass furnace, that reduces the energy consumption, reduces
and that slag was materials. Anyways, I think most of our listeners, they picture like these glass bottle recyclers, and like you put the glass in there, and one way to reuse it would just be to take that bottle, clean it out, squirt the stuff back into it, and you've got another use, right? I'm guessing that doesn't happen very often. I'm guessing that's very low.
And so currently majority of it is remelted to make new bottles in it.
Well, in the UK, it's in other countries they are far better at it. For example, in Germany and Netherlands, there's a long-standing practice in which glass bottles are also being collected for reuse. So it's just in the UK that we are not very good at this yet, but I think we could improve on that.
For sure.
There's a huge amount of energy, obviously, to melting that glass, recasting it. Let me ask you this, like, also if glass gets broken, you have to melt it to make it useful, or do you? Are there applications for broken glass without melting it?
I think this comes one of the key issues, or sort of one of my issues with the industrial symbiosis is making sure we use the hierarchy, either whether you want to call it a waste hierarchy or a resource hierarchy, and actually going for the highest environmental and economic benefit from that product. So yes, you can crush up broken glass and use it as a sand substitute, mix it in as an aggregate very quickly, very simply, but that gives you a much less, that's lost to the resource. The circular economy is lost. That's a single trip use. Whereas it's broken down, made into a new bottle, it can keep going around that loop again and again, sort of indefinitely.
So industrial symbiosis has a formal definition. So there's a European pre-standard that has specified what industrial symbiosis is. And they say that it can be defined as the use by one company or sector of underutilized resources, broadly defined as including waste, byproducts, residues, energy, water, logistics, capacity, expertise, equipment, and materials from another industry, with the result of keeping resources in productive use for longer.
Oh, that touched, as you're reading that, I'm thinking of many more. It's expanding my vision, right? It's not just like you use the glass, now let's use it for something else. It's space and tools and expertise and logistics.
Yes, it's people as well.
Yeah, that's a lot of additional capacity that is probably being underutilized or not as efficiently utilized.
Yeah, and I mean, if I could give an example of how it actually works in industrial symbiosis. So I've researched how companies are developing these synergies, and it's actually always the same process that they go through to identify and to realize the synergies. And the first step in the process is that something changes in the market context, in the legislative context, and that then triggers a synergy, because the resource use, either as an input resource or the production of a waste or a byproduct, certainly is not really a possibility anymore. So something has to change. So you could, for example, look at the use of vanadium. A demand for materials such as vanadium is massively increasing because of the energy transition. Vanadium is being used in new battery technologies, is being used in steel for wind turbine towers, for example. And we have a lot of vanadium actually in the UK in our industrial legacy waste from the steel industry. So we can refine it from those landfills, essentially. So let's say this context has changed. We need a lot more vanadium. We can't keep importing it from China and Russia, so we need to get it from here. So we're going to look for an industrial symbiosis for this, right? So then a company would identify a potential resource partner. So for example, there are companies near Scunthorpe where there's a lot of legacy waste from the steel industry. There's vanadium in there. So let's say that is going to be the partner for somebody who is making wind turbine towers. Then we're going to make an initial business case. We're going to say these are the costs and the benefits of the synergy. And if that business case looks positive, then we're going to move forward to the next step. And then what we see happening is that between the partners, they're going to develop a shared knowledge and understanding of that synergy. And really what they're after is to understand what are the mutual benefits of this industrial symbiosis. There has to be a mutual benefit. Otherwise, the synergy will not happen. And this is what sometimes people refer to as developing trust. But really, this is about making a really solid business case. So once we are there, then we're going to formalize the confidence in the synergy. So we're going to close the contract. And then we're going to realize the synergy. So we may need to build some new tech. We may need to build some new facilities. We may need to upgrade our environmental permits. Then we're going to actually deliver the synergy. And then we may think, okay, it's nice to have the synergy with my site in Scunthorpe, but what if something happens there? Maybe people living around there, they're not happy with this operation, or maybe something happens with the company that's owning that site. If you want to be really sure that your synergy can keep going, then you're going to want to secure also from another site, right? So you're going to diversify your resource partners. You're not going to keep all your eggs in one basket, so to speak. And that is the last stage then in the synergy development process, that you really develop this solid industrial symbiosis with a security of supply that can keep going for as long as you need it to keep going.
Okay. So this was a great introduction and some nice case studies so far. I think I have a much better feel for why this exists and why corporations should care about it, why we as end users, why government entities all care about this. Let me ask, it's always, sometimes you mentioned that there can be different drivers. Maybe it's going to dictate cost. Maybe it's going to be policy that changes it. But can you talk about some of the things that are driving this adoption? Some concrete examples?
For companies, often the drivers are really basic business drivers. So it's about reducing cost, it's about reducing risk. So you can imagine that if you are a producer of a waste or a byproduct, then becoming involved in industrial symbiosis usually means that your cost of your waste management are going to go down, which is nice. Also, if you are looking for alternative input resources, because you can see that demand for materials globally is increasing. We are facing geopolitical instabilities. So you may want to increase your resource security, and then sourcing it from an alternative, such as from a waste or a byproduct, can really help to reduce the risk for your business operations in the UK.
I love that you talked about resource availability. So this has been something I've been in my research talking quite a bit about, because engineers, we just make the thing. We know what composition or what processing leads to what properties, and what properties are correlated with the applications that we need. So they're like, great, let's use this material because it's the best for this application. But if that material relies on a material that is critical, meaning, and critical you can define different ways. There's not very much of that element, or it's geopolitically constrained in terms of exports. It can be a big deal. And we've seen two really good examples of that just barely, with China announcing with their export restrictions on gallium and germanium as part of the sort of, they call it the chip war, right? These things are important for microchips. And if you relied on those and you had no way of sourcing alternative materials, you're in a pinch. We saw that also in 2008 when there was a similar restriction on rare earths, right, for motors and batteries and a bazillion other things. And it caused the price to just go through the roof. Understanding resource availability and how industrial symbiosis could provide a pathway towards diversifying your feedstock of your starting materials is, I think, a cool and underexplored thing for a lot of companies.
Yeah, and it's actually, to be honest, it's not the only reason, if I may add to that.
Please.
Of course, there's the classical business drivers like that, but also companies increasingly have environmental policies. And of course, industrial symbiosis is also a great way of improving your environmental performance. Industrial symbiosis will help you to reduce carbon emissions. It will help to preserve biodiversity because we don't have to mine so much materials anymore. So we're going to save the environment, and we're going to reduce impact on water, for example, water quality. So there's a whole range of environmental benefits. And then depending on where we are in the world, it can also be that industrial symbiosis is just part of being a good neighbor, being a good member of the business community.
Yeah.
And especially in Asia, this is part of the business culture. This is part of your social license to operate, so to speak.
Okay, we've talked about what it is, why we want it, why it's a good thing. Let's talk about the challenges, right? Because there's always challenges. What's keeping us from employing this fully? What are the barriers, and technical or non-technical barriers, that are keeping us from further implementing industrial symbiosis? Chris, you want to go first?
Yes, I think so. It's difficult for me to say this as a technical person, but I think the technical barriers are possibly the ones that we can easily solve. The ones we have solved. Technically, you can do this. That you start with a material, it's got the right composition that matches a raw. Start with a waste that's got the right composition that matches a raw material. As long as you can get that cleanly and consistently, then that can switch straight into an industrial process.
Can I ask, you say that we can do that, but can we do that at a good price point, or are you putting price in the non-technical part?
Yeah, so I'm going with prices. The economics are a part of the non-technical, I guess.
Okay.
I guess there is a crossover with that.
Yeah. And what do you think?
Yeah, I would have to agree with Chris that, that there are certainly technical challenges, but we can innovate for that and usually resolve them. Most of the barriers are actually non-technical in nature. I recently had the opportunity to review extensively all of the drivers, enablers, and barriers for industrial symbiosis across the world. So I don't know how long you've got, but the thing is that often when an enabler, when a driver isn't there, then it starts to function as a barrier. And I'll give you a couple of examples of those. So one is that it is actually a collaborative culture. This is often under-highlighted. So you need to have companies, a culture that is open enough to look into industrial symbiosis and to innovate together and to collaborate. You're going to become more dependent on each other, right? You're going to create more dependencies between companies. So you need to have a culture where companies are comfortable with that. And that is not always the case. So then you have some culture change to do as part of enabling industrial symbiosis. Another example could be having a amenable policy and regulatory environment, right? So policy and regulation are super important drivers for industrial symbiosis. So for example, if we have ambitious environmental targets, for example, on recovering resources, on using recyclates, then that functions as a driver of industrial symbiosis. But if these are not there, then it can also really put the breakers on as well. Of course, one of the major barriers is that companies may not know about it. They
Yeah.
may not actually know about industrial symbiosis. This word will mean nothing to most business owners and even to sustainability managers.
I'm an
But
educator, and so I'm training workforce, and I'm wondering about workforce development. Are we training enough students that understand this? If a
no,
company, whatever company, wants to start doing this, is there enough people and personnel that grasp this, or is this
no.
like an education priority?
You're absolutely right there that we are not training enough people to know about industrial symbiosis. We are not training enough people to know about circular economy. And certainly from a recruitment perspective, I am subject to that, but also I know from many companies as well as government bodies, when they are recruiting for people with circular economy expertise who can really on the ground enable circular economy and as part of that industrial symbiosis, is very difficult to find them. So if you are new to the workforce or if you're looking for a career change, there's opportunity here.
I think maybe one of the issues there is that as an engineering degree, you probably don't study industrial symbiosis. That's part of the environmental degree, and there's not that it's seen as two separate areas. There's environmental science and there's engineering, and I think the two need for the future for this to happen in the future. There needs to be much more crossover there.
Yeah, this is the pitch of material science, right? Material science as a discipline is incredibly broad. It's meant to be broad. Sometimes say it's a mile wide, an inch deep. I don't think it's quite an inch deep. I think we learn a fair bit, but it's not like the old disciplines of the past, where if you did ceramics, like it was an inch wide and a mile deep, right? You were super proficient in how to process, make those things, but you knew nothing about the stuff around you. And we need to do big problems that require an understanding of many things. And so I think what the challenge we're running into is that it's hard for one expert to be expert all the way to the state of the art in one area and in areas around it. And so I think the only solution to that, unless we start living for 300 years or something, which, fingers crossed, we sort something out. In reality, what that means, we have to work in teams. And you have to work in teams where you can actually understand and communicate and work alongside one another to make that happen, I think.
Yeah, that's absolutely right. And one of the things that needs to happen certainly in collaboration and within teams is to generate a shared understanding about the resource flow itself, actually. So by far the biggest barrier to industrial symbiosis is lack of data on the resource flows. So to know how much of the waste and byproducts are there, and what exactly are they? So what are the qualities? What is the resource specification of that resource flow? Because that is the information that is absolutely essential for a technical person to determine whether that synergy can work, what it will do to your manufacturing site, and whether you can actually manage with that material. But that information is often not available. It's really
where are we going to
difficult
find that? Is that we just have to start doing better going forward? Is this like in company notebooks somewhere? Like, how are we going to find that data?
So actually, there is a lot of data on this already. So the UK was the first to implement a national industrial symbiosis program, starting all the way back in 2001. And it's been running until 2013. And ever since, that idea of having a national industrial symbiosis program has been rolled out into more than 40 countries around the world. And the data of this program that has facilitated tens of thousands of resource synergies has been collected. So we have a real wealth of data that we have access to in the UK, but also in other countries, about resource flows and also what kind of symbiosis have been realized already with those resource flows. So we have a wealth of data to draw on, but we do have to maintain the databases. Of course, manufacturing and resource flows, they change, they evolve over time. And when you're going into facilitating, which is a great way of overcoming some of these barriers, but if you go into facilitating industrial symbiosis, then Yeah, one of the first things to do would be to map out what kind of waste and byproducts are present among the companies that you are trying to help. The National Industrial Symbiosis Program operating between 2005 and 2013. So in these 8 years' time, they managed to save 47 million tons of industrial waste from landfill. They reduced carbon emissions by 42 million tons. And alongside of that, also saved 73 million tons of industrial water and 60 million tons of virgin material. They generated more than £1 billion in new sales and reduced costs for others for the equal amount. And at the same time, they created and safeguarded over 10,000 jobs across the UK. So these are really strong benefits of industrial symbiosis, and also really shows the return on investment. So, say if a government body wanted to invest in industrial symbiosis, then for every pound invested, you would get a really high return on investment, both in terms of economic benefits, but also social and environmental benefits as well.
Yeah, so we've recently completed last year the Environment Ash project that was sponsored by or funded by Innovate UK. So in that project, we worked with 4 different foundation industries, so the ceramic industry, cement industry, glass industry, and paper industry. Went through the whole cycle of industrial symbiosis. So we started looking at the waste materials from each of those industries, compared those waste materials, the compositions, and identified several different targets that we looked at. So we identified the waste ash material from the paper industry that had potential to work in ceramic and cement industry, waste power station ash from biomass power station that could work in cement and glass, and slate tailings from mining that could work in glass and the cement industry. We looked at those materials, went all the way through the cycle of lab-based trials, pilot-based trials, and identified that these materials could go into an industrial process. And by the end of the project, we'd actually started using some of that slate material in an industrial process in the cement industry. So it was a really great project that we went right from that beginning step, looking at the basic chemistry, all the way through to a final product that's now been routinely used in industry. So I think
that was funded through this Transforming Foundational Industries program.
Yes, that was funded by UK.
How
It was
cool
brilliant.
Success story there.
It brought everyone together, and kind of the cross-pollination. As Anne mentioned, it's not just materials, it's the skills, the experience, the knowledge that gets shared as well. And I think that's one of the great things that KTN and Innovate UK bring to materials research in the UK.
Cool. Anne?
We're not supporting industrial symbiosis at a national level anymore in the UK, but we do have some investments going into industrial symbiosis through research and innovation. So, for example, the Transforming Foundation Industries program has invested into Transfire, the Transforming Foundation Industries Research and Innovation Hub. And via this program, we are facilitating industrial symbiosis. So we have partnered with international synergies to organize workshops for companies to come together to make potential matches between the waste and the input resources that they may need. And then from that, we go on to research some of those potential industrial symbiosis through our research programs. I know that there's also Network Plus projects that have been funded on industrial symbiosis. So the Transforming Foundation Industries Network Plus has invested in some projects investigating the technical and the industrial feasibility of technical and commercial feasibility of some of these industrial symbiosis.
Okay. In this UKR series of future technologies, we're talking about the future, right? So I want you to look into your magic ball for a minute and tell me, how does this field look differently in the year, say, 2050? Or like, how will companies be doing things differently?
I think one thing that kind of relates to the previous point is sharing that information between different sectors, different companies. One of the fantastic things facilitated by Innovate UK and KTN in one of the projects I worked on was the fact that we got multiple industries together in the same project. Glass industry, paper industry, ceramics, cement, all had similar problems, but slightly different takes on it. And getting those people together, discussing those problems, sharing that data between the different industries. As Anne says, there's the data available, but making that more widely available and easily digestible to the industrial people on the ground so that they can actually make use of that data is important. So some kind of matchmaking database to help people get their resources together and set up these synergies is certainly important. And designing materials to be reused, to be brought or kept in the circular economy. So at the moment. Composites are great, as Anne mentioned, recycling wind turbines, getting materials back out of wind turbines. At the moment, that's very difficult to do, but if we can design materials with that end-of-life reuse symbiosis idea in place, that's where we need to be heading to get to this fully circular economy, resource efficiency idea in the future, and seeing these materials as resource, thinking about how we keep them in that economy.
Okay. And what do you think? What's the future look like?
I think that in the future, industrial symbiosis and circular economy will not be optional anymore for companies. I think they will have to use industrial symbiosis to ensure that they can maintain a sustainable production. I think it will also be essential for achieving climate targets. Let's not forget that 50% of our carbon emissions are coming directly from material use. So if we want to reach net zero, then we have to adopt industrial symbiosis and circular economy practices, and everyone has to be on board with that. I do agree that we will see more digitally supported industrial symbiosis. Digital systems are constantly evolving, we're learning, we're developing, and they become ever better. But actually, experience has shown that time and again that having a digital system, for example, for making resource matches, is insufficient for really enabling and accelerating industrial symbiosis. It really requires to have an expert who knows about these industries on the ground with a really practical insight in how these factories work, what kind of materials are going into it, what is coming out of it, and who can make those links between the different companies. So I think we'll always have to see a system or an approach where these digital databases are combined with experts in industry on the ground to help it.
Well, maybe one last question. Can you imagine a world where there's just no waste anymore?
Yeah, I don't want to disappoint you, but no, I think that we'll always have waste. I think waste is unavoidable to an extent. And actually, I don't believe in a circular economy with no waste and that is fully closed cycle. I think that is a scientific fairy tale.
I agree. But we can certainly do better. We can certainly minimize.
We can do a lot better. For example, in the UK, 92% of the waste that we put into our residual bin is recyclable or potentially recyclable. So there's a lot of space for improvement, and that also goes for industry. There's lots of space to grow.
Okay. Thank you both for being on the episode today. We really appreciate it. All right. That is it for today. Special thanks to UKRI. We're going to run an ad for them. We really appreciate their support for this series. It's been fantastic. Innovate UK is the UK's innovation agency. As part of UKRI, they provide over £1 billion per year of government funding for UK organizations to create a better future for inspiring, involving, and investing in businesses developing life-changing innovations. They also support innovative companies to grow through Innovate UK Edge and connect innovators with new partners and funding opportunities through Innovate UK KTN. The Transforming Foundation Industries Challenge is a program funded through Innovate UK. They recognize that decarbonizing the UK's foundation industries is a non-negotiable step in reducing global warming, meeting the UK's net zero targets, and speeding our transition to a low-carbon economy. The Transforming Foundation Industries Challenge is providing funding and support to create a cleaner, more efficient, and more competitive sector that is fit for our future. If you're an innovative UK-based business, or you're looking to innovate in the UK, find out more by searching Transforming Foundation Industries.
The Materialism Podcast is also sponsored by Materials Today. You can visit materialstoday.com to stay up to date on the latest happenings in the material science field and read some of the fantastic articles that they've published. You can also head over to elsevier.com to find out more about their journals, books, conferences, and related programs.
We would love it if you would leave us a review. 5 stars on iTunes, Spotify, Google Play, wherever you're listening to your podcast. That will help other people find the show, and that would be pretty rad, we think. Special shout out to the people who make the music for the show. That's Alphabot and Kolobyte. I know we've said this 65 times now, but if you haven't checked them out, you should do it. They make cool stuff. We dig it. Anyways, that's it for today. We hope to see you on the next episode. See you, everybody.
The inventors of fire, electricity, magnetism, iron, lead, glass, silk, cotton, the makers of tools, the captors of lightning, the architect, the engineer, the musician, are all beneficiaries of the materials of this world and are bound only by their imaginations in manipulating those materials.